Welcome to the Regents Physics Kinematics problem set, the solutions for numbers 7 and 8. We begin with these two problems, emphasizing that there needs to be a solid problem-solving approach to solving physics problems. I'm going to model one example for you here. And I'll tell you what, I'll model one way to do it in number 7, and I'll model a different way to do it in number 8. But in both cases, what we do is we start off identifying key information provided in the word problem, and then decide what we're going to do as far as a problem-solving approach is concerned. All right, so here's one of the ways preferred to do a physics problem. Let's read number 7. A bike travels at a constant speed of 4 meters per second. So we underline the key piece of information, and then over it or on top of it, either one, we write the letter used in physics to represent that piece of information. And it's a constant speed of 4 meters per second, and the symbol in Regents that we use for that is V. For 5 seconds, another key piece of information, and that's time, and the symbol we use for that is little t. How far does it go? And how far in an object travels in physics is either its displacement or its distance, both the same letter, and that's lowercase d. Now that we've identified the variables, what we want to do here is establish, is there an equation that relates the variables given and asked for in the problem? Of course, this is probably the most basic motion equation, is that the average velocity equals distance divided by time. We go ahead and we substitute in the information provided. We have 4 meters per second equals d over our time of 5.0 seconds. Notice the substitution with units. Now we solve it for d, which means we have to multiply both sides by 5. So this would be a 4 meters per second times a 5 seconds. We notice that the seconds units cancel, and 4 times 5 is 20. To make that 2 digits, because both our measurements given in the problem are 2 digits, we put a decimal point after the 0 and put our units on our answer. So this would be a full credit Regents response as modeled on the board. Okay? All right, let's go to number 8. The car is moving down a road at 55 kilometers per hour. And this problem will model for you a different way to do the question, and that is by making a list of the key information. So we'll start here with this 55 kilometers per hour, and that of course is how fast it's going, that is its speed. Okay, we'll list it as its average speed. 55 kilometers per hour. This piece of information also is given to us in non-standard units. Standard units would be meters per second, and we'll probably, though we'll have to read the rest of the problem to be sure, probably have to address that at some point. A deer suddenly runs into the road. If it takes the driver 0.75 seconds, so we'll underline that, come over here and add it to our list, and that of course is the time, to react and apply the brakes, how many meters will the car have moved before it begins to slow down? And of course, what they're asking us to find here is the distance that it travels during that reaction time of 0.75 seconds. So we can see here they want the answer in meters. We're given a speed in kilometers per hour and a time in seconds. We need to make that 55 kilometers per hour become standard units for us so that we can proceed in the problem. So what we're going to do is we're going to go ahead and do a dimensional analysis conversion, and we desire meters per second from our kilometers per hour. Let's get rid of the distance units first. Kilometers would have to go in the denominator. That means meters in the numerator. And 1 kilometer is 10 to the third meters. And kilometers cancels. Let's next address the time. Hours would have to go in the numerator to cancel out the hours in the denominator. That means our seconds goes in the denominator of our fraction, our dimensional analysis fraction. So 1 hour is 3,600 seconds, as discussed as a shortcut earlier in the course. Hours cancels. And so we have 55 times 10 to the third over 3,600. And that's meters in the top and seconds in the bottom. Go ahead and do that on your calculator. Pause the video if you need time. And that gives us, to 2 digits, 15 meters per second. Okay? Now we may proceed and go ahead with the problem. Velocity equals distance divided by time. That's the equation that relates our 3 variables. 15 meters per second equals d over 0.75 seconds. So d, we have to multiply both sides by 0.75. D equals 15 meters per second times 0.75 seconds. Seconds cancels. And when we multiply to 2 digits, we get 11 meters for our answer. Okay? All right, these are very simple motion problems, and obviously as we get further on along the unit, they'll become more complicated, and we'll continue to work on these types in class as well.